Hi everyone, let's start in on chapter 10. So you may have already read the lecture up to practice problem 1. I hope that you have. I'm going to go backwards a little bit and recap the steps for the hypothesis test. So as you can see in the lecture, chapter 10 is hypothesis testing with 2 samples. In chapter 9, we did it with 1 sample. So we're going to see those same 3 styles that we saw in the confidence intervals, and then we saw those same 3 styles in hypothesis testing with 1 sample. And I'm talking about, depending on what you're given, which type of test statistic or z-score, t-score do you find, depending on which test. So I'm going to recap that here, and so we can make a smoother transition as it gets a little bit more difficult in chapter 10 with 2 samples. So the first step is to state the null and alternative hypotheses. As you remember, the null hypothesis, we always assume there's no difference between what we are investigating and the larger population. We assume the null hypothesis. The alternative is what we speculate might be true, or what we're investigating is, do Carl's Jr. managers actually make more than the national average, right? We're going to assume they don't and try and find enough evidence that no, the null hypothesis is very likely false, and so we have this alternative to fall back on. Okay. That's even in chapter 10, all the steps are still going to be the same. We just have more difficult scenarios. Okay. Step number 2 is always to find the test statistic, and so let's recap what we're given and how that influences how we compute the test statistic. So if we are given, like the kind of the standard way and how we introduced it, if we are given a sample mean and a population standard deviation, then our test statistic is a z-score found like this, same formula that we used for the z-score back in the central limit theorem. But maybe we are not given the sample mean and the population standard deviation. Maybe instead we're given a sample mean and a sample standard deviation, S. Right? Well, in that case, it's not a z-score we're finding. Of course, it's a t-score. Although it pretty much fits the same formula, we just have S there for the sample. What makes a bigger difference here is finding the p-value that we need, the t calculator. Okay, then the very last style type of problem is that we're given p hat, a sample proportion of success. Let me go ahead and pull that up a little bit so it's not so blurry. P hat, a sample proportion of success. Now, they might not give that to us directly. They might just tell us the results of a survey. We saw that back in chapter 9 with the lawyer. Out of 200 lawyers, 63 advertised. So we had to go and compute that sample proportion ourselves, but we were given the info to do that. Okay, then we know the test statistic. It's back to a z, so we use the normal calculator for the p-value. But now this changes. We got p hat minus p. P is the larger proportion of success, divided by pq over n. Okay, so depending on the problem, changes how you find the test statistic. The test statistic is the most, if there was a most important step, it would be calculating that test statistic, getting the style right, and then obviously computing it correctly from there. After you have the test statistic, you find the p-value. Well, the p-value is the proportion that goes along with that test statistic, and at this point, we don't use tables or formulas. We use our StatCrunch calculators, and that will be true on exams as well from here on out. You'll be able to access StatCrunch. And then step 4, which is greater? Is the p-value greater, or is the significance level greater? And the significance level is told us back in the original statement of the problem, alpha, although sometimes we have to use alpha over 2. We'll see that again in chapter 10. Okay, depending on which one of these is greater, then we will know how to make the decision, is how it's referred to. The decision is either to reject the null hypothesis or fail to reject the null hypothesis. Do we have enough evidence that the null hypothesis is false, is most likely false, I should say, or do we not have enough evidence? Maybe we have some evidence, but we do not have enough evidence. And how do we decide which is which? Well, pinning back here, let's see. If the p-value is greater, do you remember which one of these it would be? If the p-value is greater, then it's actually fail to reject. If the significance level is greater, then we do have enough evidence to reject. The significance level is like the cutoff percentage, and it's pretty common to have 5%, right? 0.05. So if we go smaller than 5%, if there's less than a 5% chance of something happening, then that's enough evidence. So if this is the larger proportion, then we've got the evidence, we reject. But if we fail to get smaller than what the significance level is telling us, that we don't have enough evidence, we fail to reject. We say not guilty, if you will. Okay. I'm going to go straight into practice problem number 1 because it's rather short. It will fit well into this video. So if you haven't read that intro to chapter 10, go ahead and do that now. Okay. Practice problem number 1 is simply identifying, are the groups independent groups or are they matched pairs? Okay. Let me read the definitions. Independent groups, the two sample groups are not related as the outcome of one does not influence the outcome of another. Well, I mean, you kind of get it right there in the name. They're independent. One has no influence on the other. Matched pairs, subjects in the two sample groups have a natural pairing. Often they are actually the same subjects. Okay. Matched pairs, that phrase came up way back in chapter 1 when we were doing all the terminology. So in practice problem number 1, let's identify. So in part A, it says a company wants to know if their new windshield treatment repels water more effectively than an untreated windshield. I don't know if you guys have seen those Rain-X commercials, and they put the windshields side by side on the screen. One is treated with Rain-X and one isn't. And the one treated with Rain-X is just repelling the water, and it's just crystal clear looking through, and the one that's untreated is just a total mess. I remember those as a kid. Okay, anyway, that's basically what's going on. So they take 10 windshields. They were tested simulating rain. Okay. Then they treat the windshields and do the test again. It says the same 10 windshields were then treated and the experiment performed again. So they hit them with simulating rain again. Well, is this an example of independent groups or matched pairs? It'd be a lot more interesting to ask you in person. These are matched pairs. Okay. The windshield, it's the same 10 windshields. So they treated them, but it's the same windshield. So maybe they use a different type of glass in the different windshields. That wouldn't matter because the only difference between the first test and the second is that it was treated. All the other variables are the same. They were the same subjects. Okay, but it's the same 10 windshields. Okay, part B says it is speculated that teenagers sleep more than adults on average. To study this, a sample of 16 teens had a mean of 8.9 hours slept per night. They're doing pretty good. With a sample standard deviation of 1.2 hours. A sample of 12 adults had a mean of 6.9 hours per night with the sample standard deviation of 0.6 hours. Okay, we're given a lot of information there, but basically the groups are teenagers and adults. Well, are those independent groups or are they matched pairs? And of course, those are independent groups in part B. They're different people. The outcome for the teenagers has no influence on the outcome for the adults. Some people like to argue that and say, well, but don't teenagers grow up into adults? Well, yeah, but not in this study. I mean, there's the teens and there's the adults. They're not the same people. So here, independent groups all the way. Okay, so this is big. We need to be able to identify independent groups versus matched pairs because that changes the way we calculate the test statistic. So what we're going to do in the next 2 videos, we're going to look at just independent groups for the next 2 practice problems, 2 and 3. And then a little bit later, once we get to practice problem number 5, so we do 2, 3, and 4. Once we get to number 5, then we look at matched pairs. And finally, practice problem number 6, we're going to look at the proportion-based style for 2 samples, 2 groups. So I'll see you in the next video.